Hi, this is Larry Feldman with Lesson 2 on Function Transformations. In this lesson, we continue where we left off, which is by talking about transformations involving horizontal shifts to the right or left. And we're using f of x equals x squared as an example, g of x equals f of x minus 1, and using substitution, we sub in x minus 1 here and here. So we get x minus 1 quantity squared, which FOILs out to x squared minus 2x plus 1. In the first video about transformations, we discussed the fact that this type of transformation was a right shift by 1 unit. And I would encourage you to view that other video before watching this one to understand the background and why this is a shift to the right by 1 unit. And to save time, I did a lot of prep work here. We're plotting 5 points for f of x and g of x using x values from -2 to 2, just integers. F of x being x squared turns out to be 4, 1, 0, 1, and 4. That's simply the x value squared. And g of x is either that expression or that expression. They're both the same, just they just look different. And if we, for example, sub in -2 for x here, we get -2 minus 1, which is -3. Quantity squared is 9, so we have 9. And subbing in -2 into this expression over here gives us the exact same number. And continuing on, if we sub in -1, 0, 1, and 2 for x, we get 9, 4, 1, 0, 1. So let's take a look at this on the graphs. If we plot -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4, we get a parabola, something like this. And if we plot g of x, we have -2, 9, which won't fit on the page, -1, 4, which is right here, 0, 1, 1, 0, and 2, 1, which looks like this. So connecting the dots, you can see that we have another parabola, and extrapolating a little bit, we can see that g of x is simply a shifted version of f of x by 1 unit to the right. So let's move on to the last transformation, which is vertical shifts. So a vertical shift would look like this. G of x equals f of x plus d, where we have a couple cases. If d is greater than 0, this is a vertical shift up d units. And if d is less than 0, this is a vertical shift down absolute value of d units. We have to use absolute value since d is less than 0 in this case. So let's stick with our example. F of x equals x squared. And let's say f of x, or excuse me, let's say g of x equals f of x minus 3. Comparing that and that, we see that d equals -3, which falls into this category. Therefore, we are going down 3 units. In other words, we start with f of x, we shift down 3 units, and we end up with g of x. Okay, so let's graph this. We have f of x equals x squared. G of x equals f of x minus 3. By substitution, that's simply x squared minus 3, since f of x is equal to x squared, we just sub it right in. We can make a table, as usual, like so. We'll stick with the same 5 points. We know this is 4, 1, 0, 1, 4. Let's take a look at g of x. G of x is f of x minus 3, so we can look at the f of x column right here. And we can simply subtract 3. 4 minus 3 is 1, 1 minus 3 is negative 2, 0 minus 3 is negative 3, 1 minus 3 again is negative 2, and 4 minus 3 is 1. Or we could use this equation with the x values and get the same answers for g. So plotting these graphs, let's do that real quick. Okay, so let's do f of x as usual on the left and g of x on the right. And f of x we've graphed many times before, counting the first lesson on transformations. We have these 5 points here and our familiar parabola like this. And g of x looks like this. We have negative 2, 1, negative 1, negative 2, 0, negative 3, 1, negative 2. This one's a little bit off. And 2, 1. So we have a parabola that's down here. And it's fairly obvious that g of x is simply a shifted version of f of x down vertically by 3 units as expected. So we've covered now between the two videos all of the 4 main transformations. So now let's put them all together. When facing problems in class, in this subject, you may be dealing with 1, 2, 3, or 4 transformations at the same time. So worst case scenario is you'll have all 4 transformations, and that'll look like this. G of x equals a times f of b times x minus c in parentheses plus d. And there's a really convenient way of figuring out how points on f of x transform to corresponding points on g of x. And I wanted to show you how to do that. So let's say you have a point on f of x that's x comma y. Where does that move to on g of x? Well, it turns out that there's a very straightforward and very predictable place where it moves. The expressions are a little bit lengthy, but I think after I explain them, you'll see where they come from. The x value moves to x over b plus c, and the y value moves to ay plus d. So let's look at that a little bit deeper. If you recall from the first video, b affects horizontal stretch, shrink, and reflection over the y-axis. C affects the horizontal shift. So the x value here is only affected by b and c. And sure enough, our new x value is only affected by b and c. So we take the old x value, we divide by b. We divide by b as we discussed in the first video on transformations that b is counterintuitive. If the absolute value of b is greater than 1, it's actually a shrink, and if the absolute value of b is less than 1, it's a stretch. So we divide by b, and then we add c. So we add the horizontal shift. And if c is negative, you'll end up just subtracting. And similarly, the y value is only affected by a and d, and that's what we have here. You take the old y value, you multiply it by a, which is the vertical stretch, shrink, and reflection over the x-axis, and you add d, which is the vertical shift. And again, if d is negative, you're just moving down instead of up. If d is positive, you're moving up. So this is a very convenient way of figuring out how points map from F to G. Okay, so let's do an example. And I saved a little time by writing this function up there. Let's identify the key pieces here. A is -2. B is -1/3. C is -1. And D is +4. C is -1 because this can be written like this, x minus -1. And our discussion on this topic requires a negative sign here in order to talk about it consistently. So C is -1. So notice or recall from a few minutes ago that if we have a point on f of x, let's say it is 1, 4, and I want to know where that point moves to on g of x. So the formula, I'll just put it down here, was x over b plus c, comma, ay plus d. So we take this x value of 1, we divide it by b. 1 divided by -1/3 is -3. 1 divided by -1/3 is 1 times 1 times -3/1 because you multiply by the reciprocal. So we get 1 divided by b, and then we have to add c, so we're subtracting 1 there because we're adding -1. And then the new y value comes from a times y, so we have -2 times 4 is -8, and then we add d, which is 4. So let's clean this up and simplify. -3 minus 1 is -4, and -8 plus 4 is also -4. So that's it for now. I hope that was helpful. Please visit my website, www.lfeldman.com, for links to my mobile apps. They cover everything from algebra through calculus with hundreds of examples, tutorials, and solvers. Also, I'd appreciate it if you would subscribe to my YouTube channel and tell your friends. Thanks again. Bye-bye.